Guys, now I will show you how to filter a signal by using an ideal bandpass filter. So before we start, we need to load the wave file, which is using the wave read function. And now here I declare the YFS and bits to read the properties of the sound file. And this is the declaration for the total number of samples for this sound wave. And this is the frequency domain algorithm. So next, this is the total number of samples in the frequency domain. And next, I will combine three graphs in a subplot. So later I will show you how is the graph. And here the FFT underscore y represent the FFT signal after the conversion. And here these two lines represents the coding to create an ideal bandpass filter, which is the value which is to be zero for all range. And the second line declares the values from 300 hertz to 3000 hertz to be 1. And for the line 34, here I use MATLAB axis to declare the limit of y-axis, which is from negative 0.5 until 1.5. And line number 37 represents the uh, progress of filtering the FFT signal with the bandpass filter. So here I use the multiplication rules, which is multiply the FFT signal by the bandpass filter. So it becomes capital Y. And here the inverse Y represent the inverse FFT signal back to the original sound wave. So now I will show you how is the graph. Okay, so for the first graph, it includes three graphs, which is the original sound wave, the first one, and the second one is the FFT signal, which is in uh, time domain, and the third graph is in frequency domain. So next, the first one is the graph for ideal bandpass filter. As you can see, that is one only between the 300 and 3000. So the second one is the filter signal before inversion. And the last one is the signal which is after inversion to back to the original sound. And this is the comparison between the original and the filter signals. So the top one is the original and the bottom one is the filter signal. As we can see, the amplitude changes and the gaps between the words also changes. It becomes larger, and meaning that there is more signal to be filtered after the inversion. So that's all for this. Thank you.